Solving systems of linear equations. There are three methods for solving a system of linear equations, where two of which are numerical methods and the third one is graph-based. We will explain each of them in the following part of this tutorial. 1. Elimination method. This is the easiest method for solving linear equations if the proper conditions are met. It consists of the elimination of one of the variables through the addition of the two equations to each other. Creating the proper conditions means multiplying one or both equations by suitable coefficients, to create possible solutions to cancel the variable we choose to eliminate from the resulting equation. Then, we continue with the solution because the new equation obtained now has only one variable. After calculating the value of this variable, we substitute it in any of the original equations to find the value of the other variable, the one that was eliminated before. Let's clarify this point through a couple of examples. Example 1. Solve the following system of linear equations by the elimination method. We have the following shown on screen. Solution 1. We have two choices for eliminating one of the variables. 1. Multiplying by -3 the first equation only. In this way, we eliminate the variable x after adding the two equations. 2. Multiplying by 2 the first equation and by -3 the second equation. In this way, we eliminate the variable y after adding the two equations. Let's choose the first option. Thus, multiplying the first equation by -3 yields, we have the following shown on screen. Adding the two equations means adding the left sides and the right side separately. This eliminates the variable x because -3x plus 3x equals 0 and yields for the rest. We have the following shown on screen. Now, we can substitute this value found for y in any of the original equations, for example in the first one. Thus, we have the following shown on screen. Thus, the number pair 5, 3 is a solution set for this system of linear equations. Proof: we have the following shown on screen. Sometimes, it is necessary to multiply both equations by different coefficients to eliminate any variable, as we will see in the next example. Example 2. Solve the following system of equations using the elimination method. We have the following shown on screen. Solution 2. First, we must write each equation in the form a, x plus b equals -c. Thus, we have the following shown on screen. Now, let's multiply the first equation by 3 and the second equation by 4 to eliminate y. Thus, we have the following shown on screen. Adding the two equations yields, we have the following shown on screen. Let's substitute this value in the first equation to find y. We substitute the value of x in the first equation as it has smaller numbers, but you can substitute it in the second equation as well if you wish. Thus, we have the following shown on screen. Proof: we have the following shown on screen. Substitution method. This is the second method for solving a system of linear equations. It consists of choosing an equation from the system for expressing one of the variables in terms of the other variable and then substituting the corresponding expression in the other equation. In this way, we obtain a first-order equation with one variable. For example, in the system of equations, we have the following shown on screen. We can write the variable y in terms of the other variable x in the first equation. i.e. y equals 2x minus 5, and substitute the variable y in the second equation with this expression obtained from the first. In this way, we have the following shown on screen. As for the value of y, we have the following shown on screen. Proof: we have the following shown on screen. We have the following shown on screen. Example 3. Solve the following system of linear equations by substitution method. We have the following shown on screen. Solution 3. It is better to multiply the first equation by 3 first, to eliminate the fraction. Doing this yields, we have the following shown on screen. From the first equation, we obtain y equals 3x minus 18. We substitute y with this expression into the second equation and solve it for x. Hence, we have the following shown on screen. Now, we can replace the variable x with 10 in any of the equations of the system. For example, in the first, we have the following shown on screen. Proof: we have the following shown on screen. We have the following shown on screen. Remark: it is not necessary to make the proof after every system you solve. It is recommended, however, that you make a quick mental proof to be sure that you have correctly solved the system. 3. Graphing method. This method consists of plotting the graphs of each linear equation in the system and checking the coordinates of the meeting point, as they represent the solution set of the system. This is because at the meeting point both equations have the same values for the variable x and also for the other variable y. We discussed some linear equation graphs in the initial part of this tutorial. We explained that we need to have only 2 points for each equation given in order to plot the graph of linear equations. We will continue in this way in this part of the tutorial as well. Let's take an example for illustration. In the system of linear equations, we have the following shown on screen. We have to plot the graphs of each equation in the same figure and see where they meet. But first, we have to find 2 points from each graph that allow us to plot them. We have to choose the values of the x variable and find the corresponding values of the y variable. Thus, in the first equation, let's take for example x equals 0 and x equals 2. Substituting them in the first equation, we have the following shown on screen. We have the following shown on screen. Therefore, points A, 0, 5, and B, 2, 9, are points that belong to the first graph. Then, we follow the same procedure for the second equation of the system as well. We can take x equals minus 5 and x equals 4 and find the corresponding y values. Thus, we have the following shown on screen. We have the following shown on screen. Therefore, point C, minus 5, 0, and D, 4, 3, are points that belong to the first graph. Now, we plot both graphs in the same coordinate system. We have the following shown on screen. As you see, the intercept point is at minus 2, 1. This means the solution set of this system of equations is x equals minus 2 and y equals 1. We can confirm this graphical solution through one of the other methods discussed earlier, for example through the elimination method. Thus, multiplying by 3 the first equation of the system, we have the following shown on screen. To eliminate y yields, we have the following shown on screen. Adding the two equations yields, we have the following shown on screen. Hence, substituting this value in the second equation, for convenience, yields, we have the following shown on screen. These results are identical to those obtained through the graphing method. Example 4. Solve the following system of linear equations through the graphing method. We have the following shown on screen. Solution 4. We can create tables to have the values arranged better. Thus, we have the following shown on screen. Hence, for the graphs of the two equations, we have the following shown on screen. From the figure, it is clear that point M is the intercept of the two lines. It has the coordinates m, 2, 5. This means the solution set of our system of equations is x equals 2 and y equals 5. We can prove this solution by replacing the variables with these values in the system. Thus, for the first equation, we have the following shown on screen. And for the second equation, we have the following shown on screen. That is all for lesson 9.7.3, and the end of tutorial 9.7. To continue this chapter, please watch 9.8, Introduction to Relationship between Equations in Linear Systems. Systems of equations with one linear and one quadratic equation. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.